2 pi r by v. Okay, now substitute Rn and Vn, you'll get the time period. I'll directly write formula. You do later on the substitution. 4 epsilon naught these are very important because somewhere in the numericals, this data will be going to help us a lot. N cube h cube by m z square e to power 4. This is a time period of fluctuation, and time period of proportion is proportional to n cube and inversely proportional to z square. I think remaining all are constant. So you do remember this data. Angular velocity. I think angular velocity is like a 2 pi by capital T. So from here on you can manage it. So since we know omega equal to 1 by T. So from that what happen, omega will be proportional to this one and proportional to z square. What is it? Charge of the nucleus. After this, equivalent current for electron orbiting in nth orbit. Why do the current will come? Just now I told like revolving electron, it will constitute the current here. So what is the expression for current? I is equal to charge of electron by time period. We know time period. Just I to put that time period value here, no? 4 epsilon naught n cube h cube m z square e to power of 4. So this will become mz square e to power of 5 4. This is something very important. Current proportional to z square and inversely proportional to, you may end up any matchings. In the matchings, they may ask you like this. They'll give speed, radius, time period, current, frequency, and other side, how they relate to proportionality, they'll ask you. Can be asked in advance, matching. You have to be careful. This revolving electron, what happen, will constitute current. Rate of flow of charge should be current. And this current flowing what happen will produce a magnetic field at the center of the atom. Magnetic field at the center of atom due to the electron orbiting in nth Bohr orbit. What is the expression for magnetic field? B equal to mu naught I by 2Rn. We know expression for current. N cube h cube. This one. What is the expression for radius of the nth Bohr orbit? Epsilon naught n square h square pi m z e square. Solving this, I'll end up with mu naught pi z cube m square e to power of 7 f naught cube n to power of 5 h to power of 5. So what is the magnetic field produced at center? Proportional to z cube, inversely proportional to n to power of 5. I think this data better remember. In exams you don't get a time to really work out all this much here, even in advance. If you memorize this, remember, you'll be on safer side. Sir, such a thing can be asked in advance as possibility matchings, some information based. I think somehow if you can get the time period, remaining all other things are related to that only, and we are able to manage here. Okay, I'll proceed to now. Similarly, if an electron makes a transition, if an hydrogen atom if it makes a transition, so it is there in the, select some n equal to 3, n equal to, this is n equal to 3. When it makes a transition to n equal to 1, how do it will move? That it will jump. The photon in the energy diagram we just shown, it will make a transition, not directly. It has to what? It should revolve. So it is going to describe path like this. And I think this will, the path of electron, I'll show it. This electron, what happen is going to revolve. And finally, what happen? It will come and settle at n equal to 1. R1 is first Bohr orbit, R3 is second Bohr orbit. It will not make a transition directly. This is something very important. It will what happen? It will describe spiral path, then it will get accumulated. When it is moving here, it will give out a photon. What time it will take? Fraction of time. In that fraction of time is asking. So now few things like angular momentum. What is the angular momentum? So we know angular momentum L3 should be equal to mvr, and this should be equal to nh by 2 pi. Angular momentum in nth Bohr orbit. So what is in the third orbit? It should be 3h by 2 pi. Finally, when it landed to the first orbit, this should be equal to how much? H by 2 pi. So is there any change in angular momentum? Yes, it is. T equal to 0, and it has took time delta t. So what is the change in angular momentum? Delta L. I'll take difference of this. This will be L3 minus L1. 3h by 2 pi minus h by 2 pi. H by pi. And it took some time, no? So therefore the average torque acting on the atom. Let me write all the things here only. H by 2 pi. What is the time it will take for this transition to occur? Delta t. Then what is the average time? So what is the average torque acting on the atom? Can we find out? I gave the time, and we know change in angular momentum. So average torque acting on atom, that should be equal to delta L by delta T. Delta T is what? I'll give it. And you know H and H value, substitute, you'll get the average torque. And these are the types of questions can be asked for you. So I think there's no other way. We have to just depend on this basic formula. And the photon, what is given out, will be due to this particular path. And this delta T will be of very small interval of time. 1 hour, 1 minute, 1 second. Of order nanoseconds it will take, or 10 to the power of minus 12. In that interval of time, what all that energy given will be in the form of a photon. These are very good objective questions can be asked.